Okay, so here's our second problem. Same ideas as before, but this time it's in 3 dimensions. We've got an open box with a square base. Square base is really important because that means that it's going to be x squared in there. So we do a quick sketch. So here's our square base. It's just x by x. We don't know the height of the box though, so we'll call the height of the box y. What do we know? We know the surface area is 192 square centimetres, but we're looking for the volume. So the volume in terms of x is going to be x squared times y. So we need to get rid of this y and get y in terms of x. We know that the surface area is 1 x squared. Remember the top of the box is open, so there's no other x squared up here. And then we've got 4 lots of x times y for the 4 side faces. And we also know that instead of having 192 here, surface area here, we could have 192. So we start rearranging that now to get y on its own. So I've got 192 minus x squared equals 4xy, and then finally y is 192 minus x squared over 4x. And then I'm going to plug that back into here. Okay, so the volume in terms of x is x squared times 192 minus x squared over 4x, which gives us 192 x squared minus x to the power of 4 over 4x. You can cancel the x straight away, so get rid of that x there, cancel that out. That becomes x to the power of 1, and that becomes x cubed. And because we're going to differentiate it, we probably want to write that as 2 separate terms. So 192 divided by 4 is 48. So we've got 48x minus x cubed over 4. So that's our volume in terms of x. Just going to put a little line under that and then just come down here. So now we want to find the first derivative of the volume, because we're looking for a maximum volume. So first derivative is going to be 48 minus, and then we've got 3 x squared over 4. When the gradient of the curve is equal to 0, so our local maximum minimum point, we know that 48 minus 3x squared over 4 equals 0. So that tells us that 48 is equal to 3/4 x squared. If you divide x squared by 3/4 or times by 4 and then divide by 3, you'll get 64 equals x squared. So that means that x is plus or minus 8, but we're dealing with lengths here, so x is not going to be negative 8, x is going to be 8. Notice that I've written this down, all of this, because it shows the examiner that you understand that there could be a negative value, but because it's a practical example and therefore you can't have a negative length, you still write down x does not equal the negative value to show that you're discounting it, that you've considered it, but that you're discounting it, and that you know that the final length of the box is 8. Okay, so at this stage we do need to just prove or double check that we have the maximum value here, not a minimum, because it's a quadratic, and a quadratic curve has this shape or this shape, so we could be looking at a maximum or minimum there. So The second derivative, the 48 disappears, and this becomes negative 6x over 4, or negative 3x over 2. So then we're going to plug in, don't know what happened there, sorry. We're going to put in our value of 8 into the second derivative, and we've got negative 3 times 8 over 2. Well, you can see clearly that that is less than 0. So you've got a max at x equals 8. Now, remember, there is still one other thing we need to do. We were told to find the dimensions, and we've only found one dimension. Okay, so we also need to know what y is. And if I just get rid of this, is your homework question. I'll just move that down there. So to find y, it's, as I'm sure you know, you just substitute in. Well, I would use this, just substitute straight into this. So the y value is 192 minus 8 squared over 4 times 8. So you've got 192 minus 64 over 32, and all that will come to 4. Okay, so final answer is the dimensions are, was it in centimetres? Centimetres are 4 centimetres by 4 centimetres by 8 centimetres.